Okay. So multiplying powers, what's our rule, Luis? When in doubt, that's good. When in doubt, write it out. That's always a good rule to remember. We have the specific rule for multiplying powers. It's in our notes. Luke? Yes, good. So when the powers have the same base, add the exponents. So when the powers have the same base, add the exponents. What was the little sub note that we had for this rule? What do we do with our coefficients? Luis? So good. We're going to multiply the coefficients. And when the powers have the same base, we're going to add the exponents. Everybody got that down? So moving on, when we have powers that have powers, what is our rule? You can always refer back to your notes. Isabella? Good. So if powers have powers, multiply their exponents. So when two exponents touch, we're going to multiply the exponents. What is one more thing that we need to remember when there's powers that have powers? How do we handle our coefficients? Isabella? Good. So what Isabella says is if there's a coefficient out front, you need to distribute that power to the coefficient and make that coefficient be multiplied to, or be raised to that power. So if there's a coefficient distribute the exponent. So when you're working through it, when powers have powers, make sure you distribute the exponent to every single variable and coefficient that is in the problem. Is all this clicking in your head, remembering how we're doing this? Good. So what happens when we move on to dividing powers? Paige? So if powers have the same base, subtract what? Subtract the exponents. Good. So when the powers have the same base, subtract the exponents. So continuing with the theme, what's the second rule we have when we're dividing powers? What do we have to do with our coefficients? Luis. If the powers have coefficients, simplify them first. Good. So when there are coefficients, divide them if you can, and if not, simplify. So what can you guys tell me about negative exponents? What are our rules there? Paige? One more time, please. So what Paige said is so essentially what you're saying is we can't have negative exponents. So what Paige says is you can't have negative exponents, and if you do, if they're in the numerator, you place them in the denominator. So when you have negative exponents, move the negative exponents to the bottom or the denominator. So what happens if there's a negative exponent in the denominator? One more time, Paige, please. Good, so it needs to be in the numerator. So once again, you cannot have negative exponents. So if there is a negative exponent in the denominator, move it to the top. And one more time, why do we need to do that? You cannot have any negative exponents. Good. So when you move the negative exponent to the top, if it's on the bottom or the bottom to the top, do you keep the negative sign? you just make it a positive number, right? Because you, once again, cannot have negative exponents. So you guys need to remember that. After you move it, change it to a positive. Okay, so moving on to some review of our scientific and standard notation rules. So when you're moving from standard to scientific, what's a big number? What are our exponents going to look like? A really big number, what are our exponents going to look like? Colin? Positive. So when you have a really big number, you're going to have positive exponents. Bless you. So when you're moving to scientific notation, what's that major rule that applies to all scientific notation problems? One thing you always have to remember, Cameron. Good. So Cameron says that we can only have one non-zero digit to the left of the decimal. So when you're working with scientific notation, you need to move the decimal so there is one non-zero digit to the left of the decimal. And what do you do with your number of moves? What do we do with that count? Cameron? You're saying, do you add one to the decimal? So, when you're moving and you're counting your numbers, what does that number now become? How many times you move the decimal? What does that become? Skylar? It becomes the exponent. So you count the number of moves you make. So you count how many times you move the decimal, and that now becomes your exponent. So what about really small numbers? What does that exponent look like? Negative. So really small numbers, the exponents are going to be negative. Just to hammer that back in, just keep hammering this concept into you. What is our rule, once again, for our decimal placement? Once again, Cameron says that you can only have one non-zero digit to the left of the decimal. So you're going to move the decimal so there is one non-zero digit to the left of the decimal. And once again, when we're counting our spaces, what does that number now become? The exponent. So count your moves of the decimal. And once again, that is your exponent. So on the test on Wednesday, we should all see how many non-zero digits to the left of our decimals in scientific notation problems. 1. Uno. No dos. Just one non-zero digit to the left, and we're going to count our number of moves, make that our exponent. So what about if we're moving from scientific to standard notation? Well, so you have a positive exponent. What does that mean? What kind of number is it going to be? Big number. It's going to be a big number. So positive exponents mean big numbers. Positive exponent tell us to do? Which way are we moving the decimal? One more time. Which way are we moving it? We're going to move it to the right. So the exponent tells you how many decimal moves to make right or in the positive direction. So the exponent tells you how many decimal moves to make. And which way are we going again? To the right. So positive exponents tell you to move the decimal to the right. I'm sorry? Yeah, sorry. In the parentheses it says right means to move it in the positive direction. Sorry for the poor handwriting. Okay, so negative exponents. What kind of numbers are those going to be? Really small numbers. And what does a negative exponent tell you to do with your decimal? We're going to move it to the left in the negative direction. So the exponent tells you how many decimal moves to make. And which way is that again? To the left. In the negative direction. So it looks like we got about 2 minutes left in the period. On Tuesday, we will review the other side of this paper. You have homework. It is